Our planet Earth is a marvel, a life-sustaining oasis in the vastness of space. We often think of Earth's age as impressive, some 4.5 billion years old. But what if we told you that Earth's very materials are even older than the planet itself? It's true. The story is written in the atoms, the basic building blocks of everything around us. These atoms tell a tale of cosmic events that predate our solar system. Like detectives piecing together clues, scientists have uncovered a fascinating history of the universe by studying the composition of Earth. The Earth is composed of elements like iron, oxygen, silicon, and many others. These elements didn't just magically appear when Earth formed. They were created in the fiery hearts of stars that lived long ago, stars that existed before our own sun even ignited. When we examine the age of these elements, we start to uncover a timeline that stretches far beyond the familiar 4.5 billion years. Stars are like giant cosmic factories, churning and burning throughout their lives. Deep within their cores, under unimaginable pressure and heat, they fuse simple elements into heavier ones. Hydrogen, the lightest element, fuses into helium. Helium then becomes carbon, oxygen, and so on. This process of stellar nucleosynthesis is how all the heavy elements in the universe, including those found on Earth, were created. Some stars become massive furnaces capable of forging elements even heavier than iron, such as gold and uranium. These heavyweights are only released into the cosmos when these stars explode in spectacular supernovas. These explosions scatter the newly formed elements like cosmic seeds across the vastness of space. These scattered elements become the raw materials for future generations of stars and planets. Billions of years ago, long after the first stars lived and died, a cloud of gas and dust, enriched with the remnants of countless supernovas, began to collapse. This cloud, called a nebula, slowly rotated, drawing in more and more material due to gravity. As the cloud contracted, it spun faster, forming a disk-like structure known as a protoplanetary disk. Within this swirling disk, dust grains clumped together, growing larger over time. This process, called accretion, led to the formation of planetesimals, the building blocks of planets. These planetesimals continue to collide and merge, eventually growing into the planets we know today, including our own Earth. This process of planet formation takes a very long time, further extending the timeline beyond the age of our solar system. Our solar system, relatively young in the grand scheme of the cosmos, formed from the remnants of older stars. Scientists use a clever technique to determine the age of Earth and its materials' radioactive dating. Certain elements like uranium and thorium are radioactive, meaning they decay over time into other elements. This decay happens at a predictable rate, like a clock ticking away. By measuring the ratio of the original radioactive element to its decay product, scientists can determine how long the decay process has been occurring. When we apply this technique to meteorites, which are essentially leftover building blocks from the early solar system, we find ages that consistently point to around 4.5 billion years old. This age aligns with the estimated age of the solar system itself. However, when we analyze certain elements within these meteorites, particularly those heavier elements like uranium-238 and thorium-232, we find ages that are significantly older. Some measurements indicate ages of up to 7 billion years. This evidence suggests that the material that formed our solar system, and by extension our Earth, originated in events that predate the formation of our Sun.